Hi everyone, welcome back to this session. So in this session, let's understand how can we calculate value at risk using historical method. Okay, see the first thing is what is this historical method? You might be thinking what is this historical method? Okay. Okay, so basically value at risk, or you can say this historical method of value at risk, the historical method of value at risk is a non-parametric approach that estimates the potential loss in a portfolio based on the actual historical market data. Okay. So basically, what I'm trying to say is we'll calculate value at risk how? By using the actual historical market data. Okay. So see, any stock that you see, let's take any stock, ABC, or XYZ, any stock. Of course, we have the historical data available, right? How the stock has performed in last few years, right? We have historical data available for all the stocks, right? So what we'll do is we'll take those historical data that we have, and using those historical data, we'll try to predict or we'll try to calculate the value at risk number. So now the question is, how do we do that? Okay, how do we do this? So you can say, what are the steps? What are the steps involved in calculating value at risk using historical method? So let's look at the steps. So one more thing which I want to make you understand is always remember historical method. It just takes in the historical market data and then it tries to calculate the value at risk number. Okay. Or you can say tries to calculate the value at risk. So let's look at the steps. Step 1 is gather the data and calculate the return. So step 1 is gather data and calculate the return. What does this mean? See, basically, let's say you have two or three different stocks in your portfolio, right? Let's say, let's say you have three different stocks, three different stocks in your portfolio. So what you'll do is you'll gather the data from Yahoo Finance. Okay. After collecting, so in my example series, I have just collected 1 year data. Okay. Now what you can do is you can collect 2 year data, 3 year data, 5 year data, and so on. Okay. So first step is to gather the data from Yahoo Finance. So let's say you have the stock XYZ. So mostly in my Excel implementation, what I have done is I have taken three different stocks, which is JP Morgan, Morgan Stanley, and Bank of America. Okay. So let me use the exact name because So I have used three different stocks, which is JP Morgan, Morgan Stanley, and Bank of America. It is also called BOFA, Bank of America. Okay. So the first step is to collect the data of all these three stocks So let me write JP Morgan. This is Morgan Stanley, and this is Bank of America. So collect these. So basically, you collect the data of this three stocks from Yahoo Finance. And then what is the next step? Once you collect the data, right? Calculate the return. What is the next step? Once you collect the data, the next step is calculate the return. Okay, so one question that I see is should it be the same sector or portfolio can include different sectors? I would say it can be anything. It can be anything. If you want, you can have financial sector, energy sector together, or it can be anything. The end goal is to understand how can we calculate value at risk for a given portfolio. So whatever your portfolio is, it is there is no issue with it. It can be any portfolio. Okay. So let's see. So calculate the returns. Now the question is, how do we calculate the returns? Okay. So basically, let's say you have the following data. So basically, to calculate the returns, you'll use this formula, which is, let's say, stock price today divided by stock price yesterday minus 1. So, so we'll have stock price today divided by stock price yesterday minus 1. So first thing is you'll collect the data and you'll use this formula to calculate the returns. Now let's say you have data something like this, okay? Let's say 7th December 2024, 6th December 2024, 5th December 2024, 4th December 2024, and so on. Let's say you have some data like this. 3rd December 2024. Let's say 7th December is a Saturday, so let's remove this. Okay, so we have these data points, okay, and so on. Let's say we have this such data for last 1 year, so we have a 1 year data. Okay, so let's say stock prices are something like this: 100, 100.5, 100.7, 100.5, 100. Okay, so now these are the stock prices. Now how will you calculate the returns? Basically, today's value divided by yesterday's value minus 1. So if you see stock today, what is the price of the stock today divided by stock price yesterday minus 1. So how will you calculate 100 divided by 100.5 minus 1? Similarly, so this is the return for this day. Okay, let's say, okay, so this will be whatever value you get, this is the return. Okay, similarly, how will you calculate return for this day? It's basically 100.5, which is the stock price today, divided by stock price yesterday, which is 100.7 minus 1. So you'll get something which is your return. Similarly, how will you calculate return here? You'll do the same thing. You'll use this formula, which is stock price today divided by stock price yesterday minus 1. Okay. So similarly, you'll have 100.7 divided by 100.5 minus 1. So you'll get something. Similarly, how will you calculate here? 100.5 divided, this is stock price today divided by stock price yesterday, which is 100 minus 1. So like this, you will get this whole series of returns. Okay. Now always remember one point. Okay. Always remember one thing, that this I want all of you to note. See, what happens is if you have 252 data points. Okay, which basically means if you have stock prices for 252 days, which is nothing but 1 year, because we know that in 1 year, how many trading days are there? There are only 252 trading days, right? So in 1 year, how many trading days are there? There are 252 trading days. Okay. So let's say if you have 252 data points. So let's say what I'm saying is if you have 252 stock prices. Okay. So when I say data points, I mean stock prices. So let's say if you have 252 stock prices, you will, okay. So when you calculate the return, you will only have 251 returns. So always remember that if you have n data points, you will always get n minus 1 returns. So let's say if you have 501 data points, you'll get 500 returns. And why is that the case? Why is this one number missing? So let's say this go till, let's say, 1st January 2024, 2nd January 2024, something like this. Okay. So you calculate here. Let's say what will be the price. Let's say this price is here is 100. This is 99. Okay. Something like this. So when you calculate the return here, what will be the return? 100 divided by 99 minus 1, right? But when you calculate the return here, we don't have any point here. We don't have any data point here. Let's say this was the only data series that you have considered. Okay, these are the only data points that you have considered. So b- before 1st January 2024, you don't have any data, right? So here you cannot calculate the return. Here you cannot calculate the return, and that's why always remember, if you are calculating, if you have 252 stock prices, we'll always get 251 data points. So this is the first thing which you all should know, and this is how. So as I say, what's the first step? The first step is to gather the data, and now the data can be gathered from various sources. Yahoo Finance is the most easiest. So let's say if I have three different stocks in my portfolio, which is JP Morgan, Morgan Stanley, and Bank of America. So what I'll do is I'll first download the data of each of them from Yahoo Finance, and then I will calculate the return. How will I calculate the return? Basically, whatever stock price is today divided by stock price yesterday minus 1. So let's say this is my 1 year data. Okay, this is my 1 year data, and let's say these are my stock prices. Okay, so how will I calculate return? Return is nothing but stock price today, which is 100, divided by stock price yesterday. So if you see this formula, stock price today divided by stock price yesterday. 100.5 is stock price yesterday minus 1. That's it. Similarly, 100.5, which is stock price today. 100.7 is stock price yesterday, right? So if you see, this is stock price today, stock price yesterday minus 1, and so on. So that's how you will calculate the return. This is the first step. Step 2 is, what is step 2? Step 2 is sort the data. Step 2 is sort the data, which basically means that arrange the historical daily return in ascending order. Okay, which basically means that when I say arrange the returns in ascending order, basically it means that from the smallest return to the largest return. Okay, arrange it in ascending order. So if you see here, we get certain returns value. Let's say we have, let's say, 1%, 1.2%, 2.5%. I'm just making up certain numbers. Okay, negative 1%. Okay, and let's say negative 2%. Let's say this is the data series that we get. Okay, so I'm just writing this data series. Okay, which is, let's say, 1 point, okay, 1%, 1.2, 2.5. So we have gotten the returns. Okay, return series, we have gotten the returns, which is how much? 1%, right? Then we have 1.2, 2.5, 1.2%, 2.5%, negative 1.1%, -2%, and so on. Let's say, and so on. We have this return. So what you'll do, you'll arrange this in ascending order, which basically means that worst loss to the best profit, right? So what is the worst loss in this tell me one thing, in this five numbers, what is the worst, what is the minimum return that you see in these five numbers? What is the minimum return that you see? Okay. So minimum return is nothing but -2%, right? In these five numbers, let's say, because we'll have how many data points? 251 data we'll have, right? Because we have 252 stock prices. So how many returns data points we'll have? We'll have 251 returns, right? So let's say we have something like this. So when we arrange this into ascending order, which is the smallest return to the maximum return, right? So first is -2%, -1.1%, then we have 1%, then we have 1.2%, 2.5%, and so on, right? So this is how you convert your returns in ascending order. Okay, which is basically from your smallest return to the from your worst loss. Now this is what this return is, a worst return, okay, to your maximum return. So instead of loss, I'll say worst return to your best return. Worst return to your best return. Okay, so this is how you basically convert your series in ascending order. Okay, is this clear to everyone? Everyone. So what you have to do is you have to sort your data into not the data, sorry, sort the returns. You need to sort the historical daily data, or you can say you have to sort the daily returns in ascending order from smallest to the largest return. Okay, is this clear to everyone? Please tell, is this clear to everyone? Okay, perfect. So now let's look at, now we need to select certain confidence interval. Okay. So we have to select step 3 is confidence interval. Okay, step 3 is nothing but selecting the confidence interval. So as I said, there can be multiple confidence interval, 99% confidence interval, 95% confidence interval, right? So what we'll say is we can select any confidence interval. So let's go with 99%. So we say that we are selecting 99% confidence interval for calculating value at risk. Okay. Okay. So now what is the step 4? Step 4 is nothing but calculate your value at risk. Calculate your value at risk. How will you calculate your value at risk? See, first of all, what you have to do is you need to determine the number of observations you have. Okay. So let's say you need to determine the number of observations you have. Observation points. And when I say observation points, I mean returns. I'm looking at returns. Tell me one thing. When we consider 252 data points, how many returns will we have? Can you all tell me how many returns do we will we have? 251, right? 251 returns will have, right? So what you need to do is first you need to tell how many total return points or data points do we have for returns. This is the first step. Second step is what? You need to calculate the rank. You need to calculate the rank that corresponds to with a specific confidence interval. What does this mean? This basically means that, let's say, if I'm taking into consideration 95% confidence interval, okay, or let's start with 99, because we have selected 99% confidence interval. So how will you calculate the rank? Rank is nothing but 1% times total number of data points for return. So how much is this? 2.51. See, now rank, tell me one thing, rank is always, 1, 2, 3, 4, and so on. It can never be this. So what you'll do is you'll round it up. You'll round this number up, and when you round it up, what will be this number? Rank is equal to 3, right? So what I've done is if I let's say case 1 is when I consider 99% confidence interval. How will I calculate rank? So 100% minus 99% is how much? 1%, right? So 1% here times this is what? Total number of returns data points. How many number of data points do you have? So 251. So when you say 1% of 251, that basically means 1 by 100 into 251, which is nothing but 2.51. Now we all know. Just imagine there is a classroom, right? There are 251 people. And when I say that, okay, I want to choose someone who has a rank of 2.51, you will say, how can you choose someone with a rank of 2.51, right? It can be either the first rank, second rank, third rank, fourth rank, and so on, right? You can't select anyone with this rank. So what you'll do is you'll say, okay, what I'll do is I'll round up this rank, which is nothing but 3. So what I'll say is, okay, whosoever is present at the third rank, just come out. Okay. So what we'll do is, if you all remember, here what we did, here what we did. So here what we did, these were our returns in ascending order. Now we'll give rank 1, 2, 3, 4, 5, and so on. Up till how many? 251, right? Because once we have arranged our returns in ascending order, what we'll do is we'll assign rank. The worst is first, second, third, and so on. So let's assume for a moment, let's say this is negative 1%. Let's say this is negative 1%. Okay. Now what this is saying is, okay, select the person who is at rank 3. So I say that, okay, the person at rank 3 is this guy, which is return is how much? Negative 1%. So basically at rank 3, what's your var return? Negative 1. How much was it? Negative 1%, right? So okay, what I'll say is to calculate the value at risk, what I need to do is I need to multiply my portfolio value with this var return. Okay. So let's say my portfolio is how much? $1 million. So I'll multiply this by negative of 1%. Now tell me one thing, how much is this? So if you see $1 million, how much? This this multiplied by negative, right? So you'll just cancel it out. So how much is the value at risk number? So one day 99% confidence. Okay, wait. One day 99% confidence interval value at risk is how much? 10,000, right? So this is how you calculate your var number. Okay, this is how you calculate your var number using what? Using the historical method. Okay, so let me summarize this step basically. I hope you understood up till here, which is your step 3. So let me again summarize step 4, which is how we calculate var. See, the first step is to calculate to determine the total number of observation. Okay, so let's say we have 251 return points. Then you calculate the rank, which is which corresponds to the specific confidence interval. So when I say that I choose 99% confidence interval, what I'll do is I'll multiply 1% with 251. And what will it give me? 2.51. Now there can be no rank or at 2.51. It can be either 2 or 3. So we always round it up. So what we'll do is, okay, we say that, okay, at rank 3, whatever return you see is the value at risk return. So this, what you see at rank 3 is nothing but your value at risk return. So once you get your value at risk return, you just multiply that with the portfolio value. Okay. So you just multiply the value at risk return with the portfolio value to get value at risk, to get value at risk. Okay. Okay. Perfect. So if you see, I assume that, okay, my portfolio size is how much? $1 million. My value at risk return at rank 3 was negative 1%. So now I have calculated how much value at risk one day 99% confidence interval value at risk is, which is $10,000. So what this is saying is, okay, I have a portfolio whose worth is $1 million, and my one day, and in one day, I'm 99%, there's a 99% probability that my losses will be less than or equal to $10,000, but still there is a 1% chance that the losses can be more than $10,000. Okay. So now what this means is that there is a 99% probability that my losses will be less than or equal to 1 million, sorry, $10,000, but there is a 1% chance that my losses can be greater than $10,000. Okay. So, okay, let me take certain more examples to help you understand this process again. Tell me one thing. Okay, let's take further example to understand the historical method again. So let's say my returns are something like this: negative 5%, negative. You have, let's say you have calculated your stocks. There are different stocks you have. Okay, tell me one thing. When you have different stocks, let's say A, B, C, can you tell me how do you calculate the portfolio return? Okay, this is important. So I told you that, okay, you calculate portfolio, you calculate return. If you remember, I told you, okay, you have certain data points. What you do is you calculate price today, stock price today, divided by stock price yesterday minus 1, right? Stock price today divided by stock price yesterday minus 1. This is how you calculate, this is how you calculate the returns. But let's say if we have three different, this was the case when we have, let's say, only one stock in our portfolio. But let's say if we have three different stocks in our portfolio, how will we calculate the portfolio return? So let's say if we have if we have three different stocks in our portfolio, the way we calculate portfolio return is W1R1 plus W2R2 plus W3R3. Okay, basically what it means is W1, W2, W3 are the weights of stock 1. W2 is nothing but the weights of stock 2 and the weights of stock 3. So what does the weight means? What does the weight means? It basically means that let's say if I say that I have this 1 million portfolio in which I have invested, let's say 200k in stock A, 400k in stock B, and again 400k in stock C, right? So let's say I say that what will this give? This will total of this is nothing but $1 million, right? So now tell me one thing. What will be the weights? Weights will be how do you calculate weights is 200k divided by the total amount, total portfolio value, which is nothing but 20%. Okay. Similarly, weights 2 will be 400k divided by $1 million, which is nothing but 40%. Similarly, weight 3 is what? Again, 400k divided by $1 million is equal to 40%. So basically, what I'm trying to say here is okay, I have invested 20% of my money in stock A, 40% of my money in stock B, and 40% of my money in stock C. And if you want to validate it, what is 20% of $1 million? It is nothing but 200k, right? If you just do the math, 20% of $1 million, right? You right? What will happen? So we have four zeros and we have this, right? So how much is this? 200k, right? 200 and this is k, right? So what I'm saying here is you calculate the weights, okay? So whatever money you have invested in individual stock, okay? So what the first thing is to calculate the weights. How will you calculate the weights? Basically investment in the stock divided by total portfolio value, right? That's how you will calculate what? Weights. Okay. So this is the way how you calculate weights of individual stocks in the portfolio. Now, if you remember, I said portfolio return is what? W1R1 plus W2R2 plus W3R3. So for each day, you have, let's say, stock ABC, XYZ, and stock D. You'll have certain stock prices here, right? Using these stock prices, what you'll do is you'll calculate returns R1, R2, R3. So R1 is returns of ABC, R2 is return of XYZ, and R3 is return of D. So once you calculate the returns, right, what you do is you multiply. So now what you'll do is for calculating the portfolio return, you'll do W1R1 plus W2R2 plus W3R3, which is nothing but 20% of 0. So let's put in the value. If you see what was W1, 20% or 0.2, 40% or 0.4, 40% or 0.5. It's the same thing. So 0.2 times R1, 0.4 times R2, 0.4 times R3. So that's how you will calculate the portfolio return. Okay. You will put in the value of R1, R2, and R3 that you calculate on a daily basis, right? And that's how you will calculate your return of your portfolio on every day. Okay. Is this clear to everyone? Is this clear to everyone? Okay, I'll wait for a few seconds so that if there's any more doubts. So always remember one thing. Okay. So what we are trying to achieve is, let's revisit the concept. So first thing is to calculate the returns, right? Now, once we calculate the return, basically here when I say returns, I mean portfolio returns. Let's say W1R1, W2R2, W3R3, right? Let's calculate the portfolio return. Once we have the portfolio returns, which look something like this, right? or you can say something like this. Now let's look at some example so that let's look at some example. Let's say let's take an example of return. Let's take an example. Let's say my portfolio return is something like this: negative 5%, negative 4.7%, negative 4.2%, negative 4%, negative 3.7%, 5%, or let me not, okay, wait, negative 5%, 5%, 3%, 2%, 1%, negative 4.7%, negative 4.5%, negative 5.5%, negative 7%, negative 10%, and so on. Okay, and so on. So these are my returns of the portfolio. Tell me one thing. Now we have to calculate the value at risk using historical method. Let's try to do this. Okay, once we had the return, what was the step? To arrange the return in ascending order, right? Arrange the return in ascending order. Tell me one thing. See, you see negative 10% will be the first one that will come in, right? Then we have negative 7%, negative 5.5%, right? Then we have what? Negative, so negative 7%, negative 5.5, then we have negative 5 and negative 4.7. Negative 5%, negative 4.7%, then we have negative 4.5, right? Which is this value. Then we have 1%, 2, 3, and 5%. So this is 1%, 2%, 3%, and 5%, right? So let's say this is how we arrange our data in ascending order. This was our step. Let's say this is our first step after we have the returns. Okay. Arrange the returns in ascending order. Okay. Now we all know that we have to provide rank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these are the ranks, right? These are what? These are the ranks. Now, if you remember, what was the next step? The next step was to select confidence interval. Okay, let's say we have 500 data points. Okay, or let's do, let's select right now, let's select 90. Okay, so we are saying that we'll select how much data? So we will select 99% confidence interval. So using this, what was the next step? The next step was to calculate var, right? So when you calculate var, first step is to calculate what? First step was to determine the number of observation. Then determine what? Determine the rank. Find the return at that specific rank, right? And then last step was to multiply the var return with portfolio value to calculate the losses or to calculate value at risk. Okay. Now if you see, let's say we have 251 observations, right? And how will we calculate rank? Because we are considering 99% confidence interval, we'll multiply 1%, right? 1% times 251, which is 2.51. Let's round it up, which it will round it up to 3. Okay. Now, if there was a case that we were selecting 95% confidence interval, how would we have calculated rank? 5%, right? This number is what? 100% minus 99, 95%, right? 5% times 251. So what is this number? 12.55, right? This is 12.55. Now, when we round up this number, what will be the rank? 13th, right? Similarly, if I want to find the confidence interval at 90%, how will I find rank? 10% of 251, which is 25.1, which is I'll now okay. Now here is the question. Now here is the question. When you round 25.1, it will be 25, right? But the question is, do you need to round up or just take a round? Now, these are two different schools of thought. Okay. Now, these are two different schools of thought. Either you can round up or you can just take a round. But what I generally do is either you can take a round up or you can just take a round. Okay. So I would take round up. Okay. So when I say round up of 25.1, it will be 26. Okay. See, you can consider either this approach or this approach. But for both the approaches, you need to justify why you are taking it. Okay. For both the approaches, you need to justify why you are taking it. Okay. So what I'll say is you just take round up. Okay. So now this was the second part, which was to calculate, if you remember, we determined the number of observation, we determined the rank. So for us, what is the rank? Third. Now find the return at that specific rank. Let's come upwards. What is the return? Negative 5.5%. So this is negative 5.5%. Now you multiply the portfolio with with this, right? So step D is multiply the portfolio value with the rank, with the return at that specific at the fifth rank. So we know our portfolio value is $1 million. And what was our return? Value at risk return, negative 5.5%, right? So let's multiply this. So two zeros gone. So negative of 55. Okay, sorry. So if we remove this, there will be one more zero. So it will be also gone. Okay. So it is 55,000. So negative of $55,000, right? So what I'm saying is my loss. So so what will I say is my 1 day value at risk at 99% confidence interval is how much? 55,000. Okay, what does this mean? This basically means that or you can say negative 55%, sorry, negative $55,000. What it means is it means that the losses in the portfolio, or you can say that I'm 99% confident that my 1 day loss in the portfolio will not exceed $55,000. Okay, the losses in my portfolio will not exceed $55,000, but there's still a 1% chance that the losses can be greater than $55,000. Okay, so this is 99% chance losses will be less than or equal to 55K, and this is 1% chance that the losses is greater than equal to, sorry, losses is greater than 55%, 55K. Is this clear to everyone? Is this concept clear to everyone? How did we calculate? Do you want me to summarize it again? Do you want me to summarize it again? Summarize the historical method again? Okay. So first thing is gather the data. Step one is gather the data and calculate portfolio return. How will you calculate portfolio return? W1 R1 plus W2 R2 plus W3 R3. This is your portfolio return. Now what is W1, W2, W3? These are the weights assigned to stock 1, stock 2, stock 3. How do you calculate the weights? Basically, investment on the stock divided by total portfolio value. Okay, so this is how you calculate W, weights. And how will you calculate returns? Stock price today divided by stock price yesterday minus 1, right? So that's how you will calculate returns. So what will happen is, see, weights will anyway remain constant. Let's say zero point 0.2, zero point 0.4, zero point 0.4. These are your weights, W1, W2, W3. So what will happen is, let's say you have stock 1, stock 2, stock 3. You have some data points. You will calculate the returns R1, R2, R3, right? How will you calculate? Use this formula, right? Use this formula to calculate returns here. Once you have the returns, you'll calculate the portfolio return, which is what? You'll multiply W1, which is zero point 0.2 times R1 plus zero point 0.4 times R2 plus zero point 0.4 times R3. So for every day, you'll calculate this portfolio return, right? You'll just use this formula to calculate the portfolio return. So this was your step one, which is the gather the data and calculate the portfolio return. Step two is to step two is to sort the portfolio return in ascending order. So let's say you sort something like this: -5%, -4.5%, -4.2%, -3.7%, -2.8%, and so on, right? And whenever you sort, provide rank. This is your worst loss, second worst loss, third worst loss, fourth worst loss, fifth worst loss, and so on, right? Now, what is step three? Step three is select the confidence interval. It can be 95, 99% confidence interval, 95% confidence interval, 90% confidence interval, so on, right? You just select whatever it is. And the last step is to calculate value at risk. How will you calculate value at risk? Basically, first thing is determine the number of observation, which is, let's say you have 251 returns, right? Second step is calculate the rank. How will you calculate? For 99% confidence interval, 1% of 251. For 95% confidence interval, 5% of 251. For 90% confidence interval, 10% of 251, right? So you'll just round it up: 3, 13, 26. So these are your ranks. So basically, after doing this, what you'll do is you will look at the return at those specific rank. So look at the return at rank 3 if you are considering 99%. Look at the return at rank 13 if you are considering 95%. look at the rank at 26 if you're considering 90%. So let's say because we are considering rank 99%, so let's look at the rank 3, which is what? Which is how much? Negative 4.2, negative 4.2%, negative 4.2%. Now the last step is to multiply portfolio value with with the return at that specific rank, return at that specific rank, or you can say return at, in this case, it will be return at rank 3, right? Which is what? Multiply $1 million with negative 4.2%, which will give you how much? 42,000. So this is your loss, and this is your value at risk number. So this is what your 1 day 99% okay, so this is your 1 day value at risk using 99% confidence interval using our historical method. So these are the final steps. Is this clear to everyone? Let me scroll up so that you can check once more. So first step is to gather the data and calculate the portfolio returns. Second step is to sort the portfolio returns in ascending order. Third step is to select the confidence interval. And the last step is to calculate the value at risk. So for calculating the value at risk, you need to determine the number of observation points that you have for your returns, calculate the rank, look at the return at that specific rank, and just whatever return you get at that specific rank, multiply it with the portfolio value to get value at risk at 99% confidence interval using historical method. Is this clear to everyone? So a good question asked is what if you want to calculate 10-day value at risk at 99% confidence interval? So what you can always do is see whenever you are given different time periods, let's say 10-day or let's say 5-day value at risk at 99% confidence interval. What you can do is you first calculate the 1-day value at risk at that specific confidence interval. Okay. So once you get this 1-day value at risk, you multiply this with the square root of time. So in this case, in the first case, we have 10-day, right? So whatever var number that you get here, just multiply it with the square root of time. So because we have calculated 1-day value at risk at 99% confidence interval, to calculate the 10-day value at risk, what we'll do is, so this will give you certain value at risk number. You just multiply it with the square root of time. What is t here? It is 10. So whatever you saw when you multiply this var with square root of 10, the resulting number that you get is nothing but your 1-day, that will be nothing but your 10-day value at risk at 99% confidence interval. Similarly, if I want to calculate my 5-day value at risk, or let's say 7-day value at risk at 99% confidence interval, what I'll do is I'll take my 1-day value at risk at 99% confidence interval, multiply it with square root of time, which is 7 here. So whatever this number I'll get after multiplication it with square root of 7, this is nothing but 7-day value at risk at 99% confidence interval. Okay, so I hope this concept is clear to all of you. Is there any other doubts which you have? Which you have? Okay. So now let's look at certain advantages and certain limitations of this historical method, or you can say advantages and disadvantage of using historical method. Okay. So first, let's look at the advantage. Okay, so I see your question that why do we not multiply it with square root? Why do we not multiply with t? Because if you see in this, what I'm saying is, if you want to calculate 10-day value at risk, you have to multiply with square root of 10. So there is this question, why just not multiply with 10 and why square root of 10? So this is a good exercise for all of you to do, because when you multiply it with 10, the results, see, when you multiply with 10, okay, the result will not look good, in the sense that when you multiply it with square root of 10, see, when I say one day, when I say one day value at risk, what does this mean? We are using daily data. When I say 5-day value at risk, we'll be calculating every 5 day, we'll be calculating a return every 5 day. When I say 10-day value at risk, I'll be calculating return every 10th day. Okay, so what does this mean? So let's say I have some, let's say for stock one, I have some price, something like this. Let's say I have price one, price two, price three, stock price one, two, three, four, five, okay, and so on. Okay, instead of P1, let me actually use some value. Let's say we have something like this. So these are the stock price for a given, let's say stock ABC. Okay. So when I say 1 day value at risk, what it means is I'm calculating the daily return, which is 100 divided by 99 minus 1. Similarly, 99 divided by 98 minus 1. Similarly, 98 divided by 97 minus 1, and so on. This is my 1 day. Okay, this is nothing but 1 day. But when I say 5 day, so that means that I'll calculate the return every fifth day. So this now 1, 2, 3, 4, 5. So what I'll do is 100 divided by 96 minus 1. So this is the return that I get, is my 5-day value at risk return. Similarly, what I'll do is 96 divided by, again, 1, 2, 3, 4, 5. 92 minus 1. So now so the return that I'll consider is every fifth day. Okay, the return that I'll consider will be every fifth day. And when I say, okay, 7 day, or when I say 10 day, what I mean is, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I calculate my first return, it will be 100 divided by 91 minus 1. Because if you see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So when I say that I'm calculating 10-day value at risk, always remember, this is nothing but this is the returns, this is the returns you are doing, calculating. So every 10 day you'll calculate the return, every 10 day. Okay. Similarly, when I say 1 day, which basically means I'm calculating the return every day. So when I say 5 day, I'm calculating the return every fifth day. 10 day basically means I'm calculating the return every 10th day. So what happens is when you once you so let's say I've gotten 1 day value at risk at 99% confidence interval as, let's say, $10,000, and I want to get 10-day value at risk at 99% confidence interval. So what I'll do is 10,000 multiplied by square root of 10. This will give me 10-day value at risk. Now the question is, why are we multiplying it with square root of 10 and not just 10? And not just 10. Okay, this is the question. See, this is more from a modeling thing. Because this method is developed by JP Morgan. Okay, so the concept of value at risk is developed by JP Morgan. So when they were developing this method, they saw that they can basically convert a 1-day value at risk at 99% confidence interval to 10-day value at risk at 99% confidence interval. How? By just multiplying with square root of 10. But when you multiply with, so you just calculate this value, you calculate this value separately. Do this exercise. Calculate this value, calculate this value, and that's where you will realize that the difference between these two is nothing but square root. So if you multiply this value with square root of 10, that's where you'll get this value. Okay, what you can do is, if you just want to understand, I see Sheikh, your question is, if you want to understand why we are multiplying it with 10, sorry, why we are multiplying with square root of 10 and why we aren't multiplying it with 10, I would recommend you to perform this exercise. First, calculate value at risk using 1 day, calculate value at risk using 10-day or 5-day, whatever you want to do, and then you multiply and you see what is the difference. You'll see that when you multiply it with square root of 10, that's where you get this value, and that's where the researchers said that okay, let's make this standardized, that let's multiply whatever we are getting with the square root of time to basically get the time at 99% value at risk. Now this time can be 5 day, 10-day, and so on. Okay, is this clear to everyone? Is this clear to everyone? Okay, perfect. Now let's look at certain advantages and disadvantages of using historical method. So let me focus on advantages. So see, let me talk about certain advantages. See, the first thing is it's easy to implement. Sorry guys, my bad. Sorry, I got some call. Okay, so the first thing is it's easy to implement. Okay, the historical method is easy to implement. What do I mean is, see, if you see in the whole calculation, we didn't do anything very complex, right? We didn't do anything any complex. So that's why we say that this method, the historical method, is way too easy to implement. Okay, the historical method is easy to implement because there's there's no complex calculation. Okay, so this is the first advantage. Second is it reflects market realities. What it basically means is, see, if you see the whole process, we are actually considering the historical data of stocks. Okay, we are actually considering the historical data of stocks. We are not saying that okay, this we are not saying that oh, we assume this might be the losses, or the losses can be $10,000, $20,000. We have actually gone through a rigorous we have gone to the rigorous calculation. Use And how do we do that calculation? Using the market data. So that's why I say we are using the historical data to perform this, and that's why it definitely reflects the market realities. Okay, that's why it's reflect the market realities. And the last is no distribution assumption. So if you have seen my Black Scholes video or any quant modeling video, every time we make certain assumptions of the returns, that oh, the returns are following a normal distribution or something like that, right? We always take this concept when you always take this assumption that the returns are following normal distribution. But actually in historical method, we are not assuming anything on the returns of the distribution. We are saying that it can take any distribution. you know. So in historical method, we don't assume we don't assume that returns follow a normal distribution, making it suitable for portfolios with non-linear instruments. See, we have seen that in certain cases, if you remember back in 2020, right, the pandemic period, the COVID 2020, right, the pandemic period, we saw that, okay, the distributions of stocks were not following a normal distribution. Okay, so the distribution of the stock was not following a normal distribution, right? And that's where, methods like historical method really helps. Why? Because it is not assuming anything on the distribution of the return. It does not assume anything. So what historical method just says, okay, whatever has happened in the history will be repeated in the future. If you ask me in simple words, if you ask me in simple what historical method says, the past will reflect the future. This is what historical method assumes. Okay. So let me write here so that it's easy for all of you to understand. Okay. So in the historical method, it assumes that it assumes that past will reflect the future. So whatever has happened in the past, that is something that will happen in the future. Okay. So whatever has happened in the past, that will happen. It will be same as what we will see in the future. Okay. So this is the main assumption. This is the main assumption that this method says, or you can say this is the main assumption of the historical method, that it says that the past will the past will repeat itself, or the past will or the past will reflect the future. Okay, so always remember this method does not take any consideration about the distribution of the returns. It just say that the past will reflect the future. Okay, so these were certain strengths of this model, but of course we all have known this for long now in this thing that every model has certain limitation or has certain disadvantages. So let's look at the disadvantages. So what are the disadvantages? See, first is it relies solely on historical data. Why is that the case? See, what we say is, okay, historical method assumes that the past will reflect the future. Now, or you can say, or in other words, you can say that the future will resemble the past, right? The future will resemble the past. You can say this, right? Now, what if it does not resemble? It is, see, this condition it is not necessary that it is always true. No, it is not necessary that the above condition is always true. What is the condition? That future will resemble the past. What if it doesn't? What if it doesn't? Like, let's take certain example, right? We saw that, I don't want to specify a company, but let's say if a company is performing badly, right, in last few years, but recently because of the AI development, it has grown massively. So if we are just building this method, if you're just building this method based on historical data, it can be the case that it might not give you a accurate value at risk for your portfolio, right? So always remember that this method assumes that, okay, future will resemble the past, or you can say past will reflect the future, but it is not always true. This is the first thing. Second thing is it ignores it ignores extreme events. What do I mean by this? See, basically, what I'm trying to say here is, see, we all know that if you see in the methodology, I said that, okay, you can take 1 year, 2 year, 3 year, 5 year, and so on, right? But if you see what happened in 2007-8 financial crisis, this was the most extreme event in the history of finance, right? This is the most extreme event. Even COVID is not considered that extreme. 2007-8 is the most extreme event that you see. Okay, so sometimes, when we are calculating value at risk, we just take in, let's say, last few years of data, right? So you can, let's we take last 5 years of data. Now when we take last 5 years of data, let's say 2024 till last 5 years 2019, so when we calculate such period, we are actually missing on those extreme events like this. So that's why we always say that, okay, it's very important to understand how much data should be, or how much data points should be considered. Now, this is very much depend on the modeler, on the quant modeler, how much data points he actually wants to consider. I'll tell you why. And that actually depends on back testing. When I'll show you the back testing, it will be very helpful to make you all understand. Okay? But as of now, just understand one thing, that if we are taking last 5 years of data, it can be the case that we are not considering the major extreme events. Okay, but also remember, let's say the stocks are performing something like this. So tell me one thing, these were, let's say, let me divide this was like 10-year data, and this is the recent 5-year data. Let's say 2024, 2019 to 2009. Okay, so let's say this in 10 years it did not grow that much, but in last 5 years the stock grown massively. The stock has grown massively. Tell me one thing, what do you think, should we consider how much data should we consider? Because we know that this specific last 5 years have been extremely important for this stock, right? Because it's just growing. So something has happened at this particular point which has caused it to grow, right? Or just imagine if it was something like this, if the stock was something like this, that after the financial crisis, this stock has just saw a decline in the prices. Do you think considering this is fruitful in our study? Do you think considering this is fruitful in our study? No. The answer is no. Because we have seen that, okay, in recent years, the stock has grown massively and it's growing at the same capacity. So it's always important for us to understand that how much, and that's why I say it depends. You have to do this study that how much data points should we consider, right? But let's, for simplification, we have done is we have just considered 1 year of data. So guys, I hope you understood what is historical simulation. Okay, now let me take certain doubts which I see on the screen. So I see that I see this question that why volatility is not considered in the value at risk calculation. Okay. So now we'll see, as I said, for value at risk, there are three different methods. Variance covariance method, historical method, and the last one is Monte Carlo method. So, so to you answer your question, why volatility is not considered? So it is not considered in just this one. Okay, but the volatility is actually considered in these two. Okay, so when I'll show you that, you'll basically understand. Okay, so the volatility will be considered in the variance covariance method and in the Monte Carlo method. Okay, so is there any other questions on this? Okay, if there are no more question, I'll 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 stop the recording, and then I'll basically let's in the next class we'll see how can we implement the value at risk model using the historical method in Excel spreadsheet. So for this complete, as I said in this whole project series, what we'll be doing is we'll be doing the variance covariance method, historical method, and the Monte Carlo simulation method. In we'll understand the theoretical piece, and then I'll show you the Excel implementation followed by backtesting of the models and stress testing. So we'll see complete everything in Excel. So as of today, I've just explained you the theoretical piece of historical method. In the next class, we'll see how can we implement this method in Excel spreadsheet. So if there are no more questions, let me stop the recording.